review for our final exam. Number 1, 7m minus 5 minus m in parentheses equals 3 plus 2, open parentheses, m minus 1. So this is a basic equation. So we're going to do distributive property, that -1 and that +2. So that's going to give us 7m minus 5 plus m equals 3 plus 2m minus 2. Good. Then we're going to combine like terms. 7m plus m is minus 5. Good. Equals 2m plus 1. Very good. Then we're going to switch sides. And remember, when you switch sides, the signs change. So that's a -2m and a +5 when I move. So 8m minus 2m is 1 plus 5 is divide by 6. M equals, awesome, m equals 1. Did y'all get that? Good deal. Number 2, we got an inequality. 9y minus parentheses 5y minus 8 is less than or equal to 6y minus 4. And we're going to solve it just like an equation. So we're going to distribute that understood -1. That would give us 9y minus 5y plus 8 is less than or equal to 6y minus 4. We're going to combine 9y minus 5y plus 8 is less than or equal to 6y minus 4. So we're going to get our variables together. So that's a -6y and a -8 when you put your numbers together. So 4y minus 6y is a -2y, and -4 minus 8, -12. Now when you divide by -2, very good. Remember to flip that sign. So you have y is greater than or equal to +6. Now your answer choice is in interval notation. So if you need to do a number line to decide if you're going left or right, that's perfectly fine. And you do know you got to have a bracket on 6 because it has an equal bar. So we're looking for the notation that's going to say bracket 6 to what? Positive infinity. That's what that means, okay? Now, keep in mind, this multiple choice test, all of the ways you can get the wrong answer are going to be there on there too. Like if you would have forgotten to flip that sign, that answer could have possibly been a choice, okay? So keep little things like that in mind. But questions on this one, 6 comma, positive infinity. Okay? Number 3, it says find the slope and the y-intercept of the line 6x plus 5y equals 28. And so if I'm looking for slope and y-intercept, it would make sense to put it in a slope-intercept form. Y equals mx plus b. That's slope-intercept form because I know that the number on x would be my slope and the number added or subtracted from it would be my y intercept. Okay, so that just means solve for y. So I would say 5y equals a -6x plus 28 if I move my 6x over. Then I divide everything by 5, and I get y equals a -6 over 5x plus 28 over 5. So that lets me know that -6 over 5 would be my slope, and you do know that's the same as m, okay? And then the 28 over 5 would be my y-intercept. Now the choices, they have it as a point. So you do know if I'm writing my y-intercept as a point, the y spot has to say 28 over 5. What's in your x spot? A 0. So kind of remember that when you're looking for it as a point. Does it make sense? So that would match with A's answer. And then on number 4, they're asking you to find the x and y intercepts of 4x minus y equals 4. And so when we're looking for any intercept, if we're looking for x, you must let y be what? Very good, 0. You let the other variable be 0. So if we let y be 0, technically it's gone. So you got 4x equals 4. X is just who? 1. Do y'all see that? Now you see your choices are ordered pairs, so how would you write this as an ordered pair? 1, 0, right? Because the x has to be 1 and y is what you let be 0. Then if we're looking for the y-intercept, we're going to let x be 0. And when you let x be 0, that whole 4x is gone. You just got negative y equals 4, which that means y is a what? Negative 4, right? So what's that as an ordered pair? 0, negative 4. Awesome. Do y'all see that? Okay. Number 5 says find the slope of the line that's passing through the points 4, negative 5 and 8, negative 4. All of your formulas will be given to you on a formula sheet. Okay, so you don't have to memorize any formulas. But you do need to recognize and know how to work them. So you know our slope formula says that we're going to subtract our y's over our x's. Good. So just be mindful of these negative signs, okay? So we would have negative 5 minus a negative 4. That's what I mean, that whole, make sure you watch that double negative stuff. That makes that a plus 4, right? Then we have 4 minus 8 on the bottom. So negative 5 plus 4 is a negative 1 over 4 minus 8 is negative 4. And what do the two negatives make? A positive 1 over 4. Y'all see that? Okay. Number 6 says find the equation of a line that's passing through the point 1, 7 and has a slope of negative 6 over 7. But they want you to write the equation in standard form. So this is writing the equation of a line, okay? We did this, but we utilize the slope-intercept form to solve for B. Use it still, and then we're going to transform it to make it standard, okay? So we know that our y number is 7. The m they gave us is negative 6 over 7. And our x is 1. And so we got 7 equals negative 6 over 7 plus b, because if you multiply it times 1, it's just that fraction. Now to get b by itself, you're going to do what with negative 6 over 7? We're going to add it to the other side and use your calculator. Remember how I told you how to type this in. Type it directly in. 7 plus 6 ABC 7, because that's going to keep this in fraction form. You don't want no decimals. That's going to give you 7 and 6 sevenths. So hit second ABC to flip it to an improper, and what does it give you? 55 over 7. Good. 55 over 7. Now, the equation in slope-intercept form would be y equals negative 6 over 7x plus 55 over 7. But it asks you to put it in standard. So now you got to change this to standard form. Okay? In standard form, remember, x and y is on the same side. That's what standard form means. I want x and y on the same side. Also, you got to remember, standard form don't do fractions. So my very first task is to clear out my fractions. Second, when you move x over with y, the x has to remain positive. So if I move it and it's negative, then I got to change everybody's signs, okay? So those are the two things you got to remember with standard. So the first thing we're going to do is multiply everybody by who? 7. That's how you clear out your fractions. We're going to multiply everybody by 7. That's going to give us 7y equals negative 6x plus 55, because they're going to cancel out those 7s on the bottom, right? Then our next step is to move the x over in front of the what? In front of y. So it's negative, so if I move it, it becomes a what? A positive. So I got positive 6x plus 7y equals 55. My x is positive, so I'm done. I have no issues if I move it and it's positive. Do y'all see that? So I'm looking for 6x plus 7y equals 55. Questions? No? Number 7, we're finding an equation of a line that's going through this same point, 1, 7, but it's perpendicular to y equals 4x minus 17. Now, we briefly looked at we didn't really get into depth with perpendicular and parallel. I mentioned, but I didn't go deep. Parallel lines are the same. They look the same. They move the same. They just don't cross, okay? So in order for a parallel line to be the same and move the same, they have the same slope. Keep in mind, the way a line moves is dependent on its slope. If we're asking about perpendicular, though, the lines cross. They intersect. So in order for the lines to cross, their slopes are opposite sign and flip it. Okay, that's all you need to know. So if I'm giving you a whole equation, I want you to give me find the slope of that equation, but then you need to take the opposite and flip it to make the slope for the equation you need. Okay? So if we look at this equation, it's y equals 4x minus 17. What's the slope of that line? 4. That's the slope of that line is 4. Positive 4. Now, this thing says perpendicular though. So the perpendicular slope would mean, okay, if he's positive, I need a negative. And all whole numbers we know sit on top of what? 1. So really that's 4 over 1. So I need to flip it. That's what perpendicular means. Take the opposite and flip it. So I would need a negative who? 1 over 4. That's my slope. That's what perpendicular means. Does that make sense? That's the slope you're going to use with this point. Now, honestly, I tell students, this line is null and void. You can mark it out. Because once you find out what the slope is so you can change it, you don't need that line no more. You don't plug into it. You need to still plug into y equals mx plus what? B. That I still need my b. I don't have a b for this line. Okay? So our y is 7. The m for this line is negative 1/4. And my x is 1. So to find b, we're going to multiply that, and that's just a negative 1/4 still. And what are you going to do to get b by itself? You're going to add it to 7. Use that calculator the same way. You're going to say 7 plus 1 ABC 4 is going to give you 7 and a 4. But hit second ABC, and it tells you it's what? Very good, 29 over 4. Now this one, they want your answer in slope-intercept form. Okay? So we got y equals negative 1/4 x plus 29 over what? 4. And you know your test is multiple choice. Now, it might look up on tests that once you figure out what the slope is, if you notice that if you know that slope is negative 1/4, then you notice ain't but one choice that has a negative 1/4 in the slope spot. Does it make sense? So glance back at your answers just to see, because it might just rule it out. I ain't got to do the work if that's the only answer that's up there that has that slope. Does that make sense? Okay. Questions on 6 or 7?
I tried to do, like, on the adding that, you said it was ABC first?
You use, think about the ABC goes where the division line is. You see what it says, the division line. So if your fraction is 1/4, ABC is for that line.
Okay, so to do the 7 plus the 1/4
You say 7 plus,
plus ABC?
no. Listen to me. The division, if you got a fraction is 1/4, you got to type in 1. ABC is for that division line, the line of your fraction.
Okay,
So it's 1, ABC, then 4.
okay.
It's making it stack it like a fraction in the calculator.
And then plus your 7.
Right.
And then to get the 29 over the
Hit
4,
second ABC.
so, like
Have you hit enter?
the 2, the second number up there at the top, is
Second.
second and ABC. It don't give me the 29 over.
Hit enter.
Oh. I thought I was doing something wrong. All right, thank you.
You're welcome. Everybody see that? Okay. Number 8. Simplify. Negative 5p to the 10th times negative 5p raised to the 2nd. Now, how are we going to simplify this? Do my exponents? How? Tell me. Adam? Okay. Okay, so you can do this one of two ways. You do notice this is the same base. That's what you're saying? Good. You got the same base of negative 5p. It's in multiplication, so I can go ahead and add my exponents. So that would give us the base, negative 5p, but I raise it to the 12th. Do y'all see that? Now, when you stick this on both, because you're looking at your answer choices, the parenthesis is not there no more. So when you stick it on both, you got negative 5 to the 12th and p to the 12th. Now, what is 12? Is it odd or even? It's even, and this sometimes is what students don't remember. It's even. So if it's an even exponent, that negative 5 will change to a positive 5. Okay? So that's positive 5 to the 12th, and then p to the what? 12. Do you see that? Because that's going to make the difference between A choice and D choice. Do y'all see the difference? So you got to remember that extra step. Once you have combined your exponents, go back and look at that exponent if it's a number, especially if your base number was a negative. And make sure if it's even, you technically got a positive. If that would have been 13, it would have stayed negative because it's odd. Does that make sense? Okay. Question on 8. No? 9, it says simplify. 3m to the 5th times m to the 7th and raise it to the negative 3rd over 12 m to the 11th and raise it to the negative 2nd. Okay? So this is simplified and dealing with your exponent rules. So we first going to take care of the what? The parenthesis, good. And when you have an exponent to an exponent, what operation you do? Multiply. You multiply. It's kind of like, keep in mind like distributed property. You multiply. So you got 3m to the fifth, and this will be m to the negative 21 over 12, and this is m to the negative 22. Now you can do this one or two ways. If you want to make sure you're not confused because you got some negatives up there, I would take care of I would flip it, because you know negatives mean they flip location, right? If it's negative on the top, it got to go to the bottom. If it's negative on the bottom, it goes to the top. So that's what I would do. I would take every step to make sure I don't mess it up. So I bring M22 to the top, and I bring M21 to the bottom. Y'all see what I did? All I did was flip these two. Now combine it. You got the same M base on top, which will make that how you combine it. By adding those exponents. So that would give me M to the what? To the 27. Right now I'm just writing my M's, okay? And you still got M21 on the bottom. So you still not done. How you combine top and bottom with the same base? Good. You're going to subtract. Very good. So that's going to give me how many M's and where?
6 M's on top.
6 M's on top. Very good. And y'all know that because 27 is bigger than 21. Now, deal with 3 12s. 1/4. Y'all see that? You just reduce it like a fraction. That's just 1/4. Now, since you have an M on top, you don't have to write the 1. It's kind of understood. Does that make sense? But either is correct. M to the 6 over 4, or 1m to the 6 over 4. Do y'all see that? Okay. Number 10. It says simplify. And it looks like we're subtracting trinomials. But if you notice, the second one is out of order. So be mindful of that, okay? That you combine it right, because it's not in descending order like the first one. But you also got to do what when you're subtracting two polynomials? Very good. You got to distribute this negative on the second one, okay? So the signs on the second one change. So I personally, you don't have to rewrite it. I'm probably going to rewrite it and stack it underneath the first one. Correctly. So this 17n squared becomes a negative 17n squared. And then that 4n to the fifth becomes a negative 4n to the fifth, and negative 3 becomes a positive. Do y'all see that? Now combine it. So we got what? 2 minus 4 is a negative 2n to the fifth. Negative 2 minus 17. Negative 19 with n squared. And then 9 plus 3 is plus 12. Do y'all see that? Change the signs and then combine it. Number 11. Simplify 3m minus 7n squared. That just means I have it twice, but you still got to multiply, right? So it's called 4, but you're going to multiply the 3m times both in the second, and then negative 7n times both in the second. So what we got? 9m squared minus 21mn minus 21mn plus 49n squared. Good. and then we can combine the middle. So we got 9m squared minus what? 42 mn plus 49 n squared. Y'all see that? Okay. 12 is starting our factoring. They give you the actual trinomial, and they want you to find one of the factors. So I would just factor it to see which one I come up with, okay? So this is an easy one. We're subtracting to get 6. So without me listing all the factors, what's the main popular factor, 27? 9 and 3. And I would make sure this works out. You follow? Make sure I take the time and get the signs right. My 6 is negative, so between 3x and 9x, who has to carry the negative? My 9. 3 is going to be positive. So when I look at the choices, do you see how close A, B, and C are? That's the reason why I want to make sure you take the time and check your signs. Because they got the right numbers. It's just depending if you put the wrong sign or not. Does that make sense? So you're looking for the one that has the x minus 9. Does that make sense? $13. I'm going to do it on another slide. We got 15x squared minus 6x plus 20x minus 8. And they want you to find the correct factor. Now, this could be worked one or two ways. And it might not jump at you, and it might, I don't know. It didn't jump at me first, but this is really set up as a grouping problem. I would have combined the middle and just factored it, okay? But I'm going to show you both. It's set up as a grouping. If you look at the first two, you can take off a GCF of 3 and an x, and that would leave us with 5x minus 2. And then on the second two, you can take off a positive 4, and then that will leave us with 5x minus 2. And so we would have the 5x minus 2 and 3x plus 4. Do y'all see that? So it would be that 3x plus 4 as the factor. But I honestly didn't see grouping. But I do know in intermediate, some teachers teach grouping as a method to factoring a trinomial. And we don't in this building. Okay, we don't, because that's a little extra. We tell you make it a trinomial and find out your first and last terms and make, you see what I'm saying, to make the middle. I would have made this 15x squared plus what, 14x minus 8. And we know that we're subtracting. And in the front, we are going to use 3x and 5x because we wouldn't use 1 and 15. And in the back, we're going to use, what, 4 and 2? And we're going to do 4 here and 2 there because this is 6 and 20, right? And if you subtract those two, you get a 14. This is the way I would have done it. And then with 14 being positive, I need a positive 20. So that means my 4 has to be positive. And my 2 is going to be negative because that's how I made 6. Does that make sense? You get the same two factors because them the only two factors of that polynomial. Does that make sense? But I did want to show that you could factor it, but you could group it. If that was I wouldn't have noticed grouping. Personally, I would have just factored it. All right. 14. You got 3x to the third minus 3x squared minus 60x. And what you got to do here first? GCF of 3x. Good. If you take it off, we have minus x, right? Minus 20. And then you're not done because you can break down that parenthesis. We are subtracting to get that understood -1. So right off the dome, what two numbers out of 20 you know make 1? 5 and 4. Good. So we got x and x, 5 and 4. Who's going to be negative when you got a 4x and a 5x? My 5. Good. Because my 1 is negative, so my 4 going to be positive. And bring down our 3x. But all they want you to do is find the right factor, so the ones of their choice is going to be who? The x minus 5. Do y'all see that? Okay. 15. You got 49m squared minus 16n squared. This one is difference of squares. So this is one of those easier ones. We got the same stuff, different what? Signs. So what goes in the front? 7 m's. What's in the back? 4 n's, and one of them positive, one who? Negative. Very good. Do y'all see that? We got 25x squared minus 60xy plus 36y squared. So this one, you're going to factor because we're adding to get the middle. And it's really considered, in the book, it was considered a special problem, but it really is not. But it was because if you look at the first number and the last number, we're still perfect squares, okay? And I'm adding, so that's the key. I got to be adding to get the middle. What this one is going to give us is the same everything. Same front, same back, and the same sign because my middle doubles. Does that make sense? So if we do square roots, we're talking about 5x's in the front and 6y's in the back, and my 60 is what? Negative, so they both got to be negative because that's going to make a negative 30 twice. Do y'all see that? So it's really the same parenthesis twice. Does that make sense? Okay. 17. W squared plus 5w plus 8. Okay? We're adding to get the middle. And when you look at 8, it only has 2 factors. Did those 2 factors add up to 5? No. So this is what? Prime. Very good. Very good. Now, I told my class on yesterday, you could have one like this, x squared minus 4x plus 5. And we're supposed to do what to get the middle? Add. So there's only one factor of 5. Will that add up to 4?
No, because it has the same sign.
Very good. And I, as a student, they were getting puzzled over it. And I said, don't try to make this work. If that was a subtraction sign on the end, it was subtract a 4, but it ain't going to add up to no 4. Does that make sense? They might throw one in there that's going to be kind of wishy-washy depending on if you're not confident in what you're supposed to do as far as operation. You follow me? This one is kind of very easy because there's no way possible if I add or subtract, I'm going to get a 5. Does that make sense? Not with 8. None of its factors going to make 5 either way. Unlike this 5, if I go the other direction, which is subtract, I can get a 4. Do you see the difference? So I want to make sure you're confident in knowing whatever that back sign is, it has to legitimately add. 1 and 5 add to 6. All day, every day. Does that make sense? So don't sway on your operation. Make sure you know it takes 2 negatives or 2 positives to add up anything. Opposite signs is subtraction. Okay? So I just want to point that out, that I don't know, sometimes they can be a little tricky. Not intentionally, but 18 wants you to solve for x. So you got 5x squared plus 2x minus 3 equals 0. So if we're solving, we still got to factor first. So we are subtracting to get the 2, and you don't have any options on the front or the back. You got to use 5x and x and 3 and 1. But I would still check to make sure these signs are right. 5x and 3x to make a 2x that's positive. Who got to be positive? My 5. So that would be on the 1 and the negative on the 3. Now, once it's factored, you now got to do what with each parenthesis? Set them equal to 0, because that's where x is. In order to tell me what's x, you got to set where x is equal to 0. So that's going to give us a positive 3/5 and a negative 1. Those are your two answers. Negative 1 and a positive 3/5. Y'all see that? Okay. 19 wants you to solve. And we got y to the third plus 2y squared minus 8y equals 0. What do we do here? First, factoring our method. What are we going to do? GCF, take off a y, and that will leave us with y squared plus 2y minus 8. And so now we're going to factor that parenthesis. We're subtracting to get 2. 4 and 2. And since my 2 is positive, my 2y, my 4 has to be positive as well. Very good. And that's important. Now, you bring down that y in front. Now, we did not focus a lot on this, but I want to make sure you understand. When I said on the last problem, wherever x is, or your variable, you got to set it equal to 0. So when we're solving, we know we got to set the parenthesis equal to 0. But don't you also have a y on the outside? You got to set it equal to 0 as well. You always set the variable equal to 0. So if you had just taken off a GCF of like 2, that has nothing to do with 0. You follow what I'm saying? But you took off x, that equals 0 himself. You took off y. So it's any variable. Does that make sense? So we know we got a negative 4 and what, a positive 2? But you also got to include who? 0. Very good. You got to include 0. And let that kind of be your guide. Look at number 19 versus 18. On 18, your highest exponent is a what?
It is an x squared.
Is a squared, a 2. That means you're going to have 2 answers in the algebra. That's what that means. On 19, what's your highest exponent? It's to the third. That means I got to have how many answers? 3. Did y'all see that? Questions? All right. Now, I do want to make this notation. If you notice, since number 12, normally on a test, a final exam, we take 2 problems for every section. We done 12 through 19 so far. Has all been factoring. Do you see how factoring is the sole component that we want you to get out of intermediate? Do y'all see that? And even on 20, 21, 22, 23, 24, I'm still really doing factoring. Do y'all see that? The bulk of this test has most of its questions from our factoring section. And that section right after, when we did rational expressions. Okay? So on number 20, I'm asking you to simplify this rational expression, but you're going to have to do what to simplify it? Factor it. So you take the top, separate from the bottom, and we're what, subtracting to get 4? So the most popular factor of 32 off your head is what? 8 and 4. Will that subtract to give you 4? Yes. So I would take the time, do my outside, inside, get your signs right. So with a positive 4y, I need a positive 8. Very good, and a negative 4. Then on the bottom, we are adding, so it's 72, 9 and 8. And I would let 8 or 4 be my guide when I'm trying to think it to 72, because you know something has to cancel, right? And both of these are going to be positive, because 17 is positive. And then obviously who cancels? The plus 8. So we're left with, very good, y minus 4 over y plus 9. Do y'all see that? Okay. 21. Find the values over the rational expression, blah, 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 is defined. Write the answer with the symbol cannot equal to. Really, that should have said what values make this undefined. That's why it said use the not equal to sign. So this is where I asked you specifically about the denominator. What numbers can I not let x equal because it will make me get a 0 in essence? So again, because they didn't give you just like x plus 2 on the bottom, they gave you a trinomial where you have to factor. So you're going to have to factor to see what you have on the bottom. And we're subtracting. So what two numbers from 63? 9 and 7. Good. And if I got a negative 2x, I need a negative 9x. Good. Now, so this time you got two numbers on the bottom. If you don't see it, which I hope y'all would at this juncture, set it equal to what? 0. Okay, set it equal to 0. So that would mean x can be what two people? Positive 9 and negative 7. Y'all see that? And again, see how close A and C answer? That's just if you mess your sign up on the factor. You're going to get the other one. Okay. 22. All right, so this is a multiplication, and we're just going to take each top and bottom separate. Now, the first one looks like just a trinomial. So we are adding to get 12. So what two numbers from 35? 5 and 7, good. Both positive? Yes. On the bottom, we're adding to get 7. 5 and 2, both positive? Yes. Now the top is not a trinomial, so what is the only thing I can do to that?
Use the k-squared and factors of
Greatest common factor. You only have two terms, so that's gonna be GCF. Do y'all see that? So I take off a k, and I got what, k plus 3 left? And then on the bottom, that's a trinomial. So we're what, adding to get 10? What two numbers? 3 and 7. Both positive. So now you get to cancel out the things that's alike on top and bottom. So that would be my plus 5s, k plus 7, k plus 3. So we're left with a k on top and k plus 2 on the bottom. Do y'all see that? Okay. 23. Got another rational expression, but this is division, which is worked very similar to multiplication, but you got to do what with that second one? You got to flip it. Very good. So on my way over there, I'm going to go ahead and reduce the first side. So on the top of that first one, now it's two terms, so what's the only thing I can do?
You can get GCF of 3x.
GCF of 3x, good. That'll leave me with
3x.
minus 1. You do have to put that minus 1, good. On the bottom, you still got two terms. What's the only thing you can do?
3x GCF.
3x GCF, and that leaves us with 2x plus 5, right? Okay, good. Change to multiplication, and whatever's on the bottom, you're going to do for your top. Does that make sense? So I'm looking at that 2x squared minus 5x minus 25, and I'm going to have to factor that into what? Two binomials? We are subtracting to get 5. So I know I'm going to use 2x and 1x. That's all I can in the front. And in the back, we wouldn't use 25 and 1. So we're going to use 5 and 5. And that makes 10 and 5. So to get a negative 5x, who has to be negative?
The 10.
The 10, which will be the 2 times this 5. It will have to be my negative. This one is going to be positive. Does that make sense? And then my top is my new bottom, and we are subtracting to get that 1. And in the back, we can't use nobody but 1. So we have to use 2x and 3x, right? So to get a positive 1, you got 2x and 3x. Who would have to be positive? My 3x, my 2x would be negative. Do y'all see that? Now, the fun part. You cancel out the 3x's. 3x minus 1. And what else?
2x plus 5.
2x plus 5. Good. So left on top is x minus 5 over 2x plus 1. Questions? Okay. 24. Perform the indicated operation. This one is a subtraction. Okay, so we first got to factor these bottoms, right? So we got x plus 3 and x plus 1 on that first one. And on the second one, we're going to have x plus 2 and x plus 3. And remember, in order to add or subtract, you gotta have a common denominator. So when it's something like this, you gotta use everybody. Whatever's on the bottom, you need to have a representation of everybody that's down there. Does that make sense? So we gotta have the x plus 3, x plus 1, and who else is represented? X plus 2. Does everyone see how we get that LCD? You don't need to write the x plus 3 twice, because both of them have it one time. Do y'all remember us doing this? And then you got to show a 1 and you got to show a 2. Now what we're going to do is we're going to divide into the bottom, and then you got to take it and multiply it times the top. Okay? So what that means is whichever parenthesis is not on the bottom, because the same parenthesis cancel. Y'all remember me talking about this? The same stuff cancels out. But the one that it doesn't have is who you take to the top. So on this first one, who has to go to the top? The x plus 2. That's what you're going to multiply 2 by, is x plus 2. Do you see that? So if you multiply that, wouldn't that be 2x plus 4? Do y'all see where I got that from? Okay, I'm going to do the same thing on this bottom one. I'm going to divide, which means the one that it does not have, you got to take to the top. So which one does it not have? It doesn't have that x plus 1. So I'm going to multiply this one by x plus 1. But keep in mind, that's a negative 1 now. Does everyone see this is negative 1? So wouldn't that make that a negative 1x minus 1? Y'all see that? And then we're going to combine like terms. We have 2x minus x is what? What's 2x? Y'all see where I am? I'm going to combine those, and then I'll combine my whole number. So that's just x, right? And what's 4 minus 1? Positive 3. Are you done? Okay, you put it over your bottom. Are you done, though? What happens? The x plus 3 cancels. So your whole top canceled out. So what's understood to be left up there? What's the holding spot? What has to be up there? A 1. Good. Over. Very good. 1 over x plus 1, x plus 2. Do y'all see that? All right. 25. Square root of 361 over 289. Now this one is a little bigger than your table. I gave you one that wasn't on my table. But you do have a calculator. Okay? So I would type it in because it's going to be a perfect number. It's going to be like that on test. So type it in and see what the square root of 361 is and what's the square root of 289. 19 over 17. Good. 19 over 17. Do y'all see that? Everyone knows how to type it in the calculator?
So you do the square root first, the x with the 2, or
You got to hit second
second?
and the X with the 2 because it's a light color button.
Okay, that's 19, okay.
These.
Second, x squared, and then up. Thank you.
You're welcome. Okay. Then 26, we have the square root of 98 x to the 5th. So you would need your table because 98 is not a perfect square. But what perfect number would be in 98? 49 times 2. So we know the square root of 49 is 7. Now leave a little room and you got the square root of 2 inside. Now deal with your exponent. You're going to divide 5 by who? 2. So how many x's can come out? 2. 1 left over. Very good. Do y'all see that? 7x squared, square root of 2x. Does that make sense? Okay. 27, you got negative 64 to the 2/3 power. So that means we're going to take the what first?
You're gonna take the third, the cube root of -6.
Cube root of negative 64, which is negative 4. Awesome. And then do what? Square it, and that gives you, is it going to be what now? Negative or positive? Positive, because you're squaring it. Remember, anything even comes out positive. Does that make sense? Even power? So that's 16. Okay. 28. 49 to the 9/8 power over 49 to the 5/8 power. What you do here? You're going to subtract the exponents. Now, the thing I always have students forget, keep the base right now. Write that 49. And then you raise it to the what power?
The 4.
4/8.
And then
Now, and this is what I noticed on tests. Some students don't want to reduce it. That reduces. 4/8 reduces to a what?
it'll be 2.
Is it 2 and 1/2?
It's 2.
It's 1/2.
Oh, okay.
Come, Miss Amanda. It's 1/2. Because your 8's on the bottom. You see that? So it has to be 1/2. And then you got to keep it going. What does 1/2 mean as an exponent?
Means it's, you square the 49.
Take the square root of 49, which your answer is 7. Do y'all see that? And do you see how easily, now that one could have been messed up, because there, you see you told me square, you squared and that 49 got a 2 on it.
Yeah, like if I would have just put a 2, it would have messed it up.
Yes, but it's probably 1/2. Do you see, you see how just the little things, we be working so, and we know what we're doing, but it just, and this one is raised to the 1/2 power. So what I would do is stick this 1/2 on what? Everybody, each one of them. Because it also goes on to 81, right? Keep in mind, you're going to distribute this 1/2 to everybody inside as far as exponents. Does that make sense? So just so I won't mess myself up, this 6/2, and then this would be negative 4/2. Do y'all see that? When you multiply by 1/2. If you multiply those 6 and negative 4, it's going to be on top of the 2. Does it make sense? I hadn't reduced it yet. I just was writing it out. So that would not, if I do my variables, that would be obviously x to the 3rd and y to the negative what? 2nd. And you could have just done it all in one step. And what does that mean with the 81? Square rooted, which is 9. Very good. So the only other thing you need to do is what? Take this negative one to the top. Very good. Because there's nothing for you to combine. So you just got whole number 9, x to the 3rd, and then y what? To the 2nd. Do y'all see that? You didn't have no x's to combine or y's to combine. The point of this problem was to see if you knew how to multiply those exponents. Does everyone see that? Okay. 30. We got negative 3 square root of 3 plus 5 square root of 12. And we want to add it together, but they got to have what? The same radical. So we got to break down this 12. as what?
4 times
4 times 3, the square root of 4 times square root of 3. And we know that the square root of 4 times, remember the moves, times that 5 that's out there makes that a what? Good. And we just bring this on down, the negative 3 square root of 3. So, we get who? 7. Do y'all see that? We just straight gonna add those coefficients. Negative 3 and a positive 10 is 7 square root of 3. Do y'all see that? Okay. 31, we're multiplying. Square root of 3 minus 5 times the square root of 2 minus 2. So this is just straightforward, isn't it? We're going to multiply by the square root of 3 and then multiply by negative 5. So the square root of 3 times the square root of 2 is just who? Square root of 6. Very good. The house don't disappear because they ain't the same people. Does that make sense what I'm saying? Okay, square root of 3 times negative 2. Square root of 3, good. Negative 5 times square root of 2. And negative 5 times negative 2. Very good. Can you combine any of this junk? Nope. Everybody's different. So that's your answer. Do y'all see that? $32 says rationalize the denominator. That's a $10 word for divider. How you gonna get that the square root of 6 off? Multiply by the square root of 6. That's rationalizing. Good. So that gives me 7 square root of 6 over 6. Now, if 7, whole number 7, and 6 would have been something alike, you do know to reduce. Okay? Good.
I have a question.
Yes.
Why is the square and the square root of 6 to 6?
Because what is the square root of 6 times square root of 6?
Okay.
Which is what?
That's what threw me off.
But that's just a known root. Anytime you multiply a square root times the same square root, it's just that number. The house going to cancel because all you're going to do is take the square root of that number. Does that make sense?
Yeah. It was just throwing me off. I didn't know how we got that root of 6.
Ta-ta-ta-ta. 32. No. Did I skip somebody? This 33. I knew I was going to be at the end. Thank you. Square root of 3 over square root of 11 plus 2. Now, how you going to rationalize a binomial? Very good. You're going to multiply by that opposite, which will be the minus. Square root of 11 minus 2. Good deal. Now, this one is a little different from the ones I worked in class, because the ones I worked in class, my top number was a whole number. And I just left it alone. But I need you to think. That's a square root number. Square root of 3 ain't going to cancel with nothing on the bottom. So go ahead and distribute it, okay? You follow what I'm saying? This number, if it would have just been 3, I would have just left it 3 and that binomial. But that's because I knew 3 could reduce. Square root of 3 ain't finna reduce with nobody on the bottom. Does that make sense what I'm saying? So I personally, especially if you wanted to match your answer choices, I would just go ahead and distribute it. So that would mean I would say square root of 3 times the square root of 11, square root of 33, and then square root of 3 times negative 2. Very good. Negative 2 square root of 30. Y'all see that? Now on the bottom, I'm still going to do just the first 2 and the what? Last 2. So that would just be 11 minus, minus is always minus. Minus of what? 4. Do y'all see that? 11 minus 4 would give us who? 7, right? And that can't be reduced. Because you didn't have no whole number left on top. Do y'all see that? Y'all see how close A and C answers are? You see what I'm saying? It's just the little stuff. I've even had students that will work the test, the problem right, and mark the wrong answer. Like they'll have it on the scratch paper, and then they marked, by quickly looking, they marked C. But they had A answer on their paper. And I've got to go back and give credit for that when I catch it, okay?
I think I've done that before.